Hi, I'm very proud to show you this. This is my new induction system for my L28 motor. It's been a long work in progress. It's a lot of design considerations and other elements, and even though it did perform very well as it was before I made some changes, um, I thought there was always still a bit of room for improvement just based on a couple of things that I've recently come to understand about airflow and the way that air moves through a pipe. Thank you very much to people like Jake Bain and Darren Morgan, whose videos have been absolutely incredible about the amount of knowledge that they have been sharing with us and the ideas behind what they know and how to incorporate it into your own system. They don't talk about sixes like this, but airflow is airflow, and it's very similar in concept, so you just have to sort of tweak it slightly to make it all suit and adapt to your own application. All right, so here's the inlet manifold that I'm using. This is a Lynx Australian designed inlet manifold by Lynx Engineering. It's designed for the Nissan L series 6-cylinder engine. You can see the 6 runners. So my modifications for this manifold extended to match porting. So I've ported the runners out at this end to match the cylinder head port. It's 37 millimeters, and then it transitions from 37 up to 45. Now, it includes phenolic insulators and these things, which I'll talk about shortly, but they're all match ported as well, so there's absolutely no flow restriction in either direction. And we'll talk a little bit more about that as well. But the thing is, it's all been match ported. Each one's been match ported to the cylinder head and to the manifold extensions. Now, these things have been created by a company called Zamco Engineering, just here in Blacktown in Sydney. They're wonderful pieces. They're my own custom idea, in the sense that I wanted to move the throttle bodies away from the inlet manifold. Convention has it that the throttle bodies themselves, or carburetors, are always attached directly to the intake manifold because of the throttle position layout with the throttle rod that sits on the firewall, and that's how I've always seen it being done. I guess the other limitation too is space, and of course you've got McPherson struts and things living inside the engine bay, which limits how long your induction system can be. But regardless of that, my engine bay doesn't have that. I have a double wishbone suspension, and I have these great acres of property that allow me to extend the intake manifold out. So the first thing I wanted to do was to try this and move the injectors further away from the inlet manifold. Now, as I said, there's a number of reasons why I wanted to do that, but primarily it's because of mixture preparation. The injectors, which aren't fitted at the moment, are sitting at an angle there. They're 30 degrees to the axis, to the horizontal axis. And as they inject in there, whilst they're very good at doing their job, what they were doing previously was they was injecting straight into the intake manifold, which has a couple of problems, and one of them is it transitions from 45, in this case, to 37. So the airspeed is not constant, it's not linear. It accelerates, and whilst it accelerates, it expands. And if you think of something like a slinky, it's being pulled apart. So the density is less, and that's exactly when you're trying to add fuel to that. And the problem with all of that, yes, sure, it probably keeps in fuel vapor form more efficiently, in the sense that it's less vacuum or less pressure there, so it creates a bit of a vacuum. But the other thing too is that it changes direction. As you can see, it's changing direction. So you're injecting fuel into an area where it's changing direction and it's changing its airspeed. So my thought was, well, if we can prepare the mixture a little bit better than that, potentially, let's inject the fuel into an area that's in constant diameter. So these are pro race throttle bodies. They start from the airbox side, which is 50 millimeters, and they transition to 45 on the exit. And the throttle blade's obviously in here, and that's about a 47 millimeter throttle blade. So what's happening is the fuel is injected here, and it runs into the manifold extension. Now this is a constant 45 millimeter diameter, and what that means also is that it's a nice stable airflow running through there. It's constant velocity, stable airflow, and so it should pick up the fuel and keep it atomized and continue to mix it with the air as it transitions from the throttle body through into the intake manifold before it attempts any diversion or any changes in cross-sectional area. And I think that's going to be one of the key advantages of this setup, is that it gives you a longer time for fuel preparation, and it also gives you a bit of a ram effect as well from the fuel being carried through there. It's cooling the air down. It's being injected into air that's being fed by this air box and the cold air induction system. It's arguably the best way that I can do it. Cold air, filtered air, good fuel mixture preparation, and therefore I believe that this setup will give me extra power and torque above and beyond what I was having before. The transition effect is 50mm trumpets. The internal diameter of the trumpets is 50mm. They're actually inside there. So it goes through the pro-race throttle bodies, which transition from 50 to 45, goes through the manifold extensions, which are 45, and into the links manifold, which is a 45 through to 37mm. The ports in the head are 37mm, and they carry through until they go to the back of the intake valve. So this is pretty much my setup. I'm hoping, as I said, to get some excellent results with this. It's a little while still, maybe a week or two, or a couple of weeks before we get this back on the dyno. There's still a couple of things I want to sort of address. They're just minor detail things. They're nothing specifically radical or anything like that, but this setup should be ready to go very soon. And then, of course, when I do that, I'll put it on the dyno and we'll do some testing, and we'll see how it works. But in theory, it should work very nicely. Broom, 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 broom. Thanks for watching, guys. I hope that's giving you a bit of an insight as to what we're doing here, and talk to you all very, very shortly, and with more information about how this all goes. All right, thanks very much. Bye for now.